Welcome to the fifth session of Smart City Waters webinar. I am Jason Mahmoudi. I'm so happy that you all could make it. Thank you so very much. I first of all have to apologize in advance if you have to deal with my voice as well as my upcoming coughs. I am recovering from COVID-19. Tested negative recently, but it's still an ongoing process for my coughs and my feelings. So accept my apology in advance. But since we already scheduled this webinar, we had to stick on the plan and then keep going with the plan. So again, thank you so very much for making this time. Make sure that you follow us on Twitter, as well as our LinkedIn page, as well as our YouTube channel, because every session, including this session, which is already being recorded, are going to be published on our YouTube channel. So if you guys miss any part, or if you want to repeat, or if you want to share it with a friend or colleagues or your team, feel free to go to Smart City Water YouTube channel and then just provide the videos to your colleagues. Okay, I will start my presentation about low impact development. Make sure you also stay tuned about the next sessions of Smart City Waters webinars. It's going to be every other Wednesday. The next one is going to be July 20th, and then the one after is going to be August the 3rd. July 20th is going to be about the functions of GIS in OTTHYMO. And then August 3rd, it's going to be the first part of dual drainage modeling in VOSWIM. We're going to have two parts for that webinar. The first part is mainly we're going to focus on the theoretical and presentation aspect of it, and also we're going to start working with VOSWIM and start modeling, and then the second session we're going to finish a dual drainage package. I am going to bring up my slides, and also I'm going to cut my video off just to make sure that the network performance of mine is going to be better. Just a heads up for you guys in advance, I tried to mute my thing, but if I forgot to mute myself, I'm sorry. Welcome to Smart City Water, the fifth session of Smart City Water's webinar. We're going to talk about LIDs, also known as low impact development approaches. I am Jason Mahmoudi, water resource engineer and climate scientist, and I work as a technical specialist at Smart City Water. The agenda of this presentation is we will start talking about what exactly is LIDs and the different types of LIDs, example of LID in Visual OTTHYMO at the end. So low impact development is technically a micro-scale stormwater management practices that mimics the nature of the site. So, but why do we do that? It is for any small size projects, it is a very beneficial, in so many cases, very cost effective and cost efficient ways to control the flooding and also control the water quality as well. So in terms of stormwater control, LIDs can do both water quality and water quantity control. Different types of LIDs. So technically we do have two types of LIDs. One is non-structural, the other one is structural. The most common ones, the most used ones are the structural LIDs. So the non-structural LIDs are known as, for instance, if we just try to stay provides us, decrease the imperviousness. If we are going to have a land development, if we want to, let's say, have a parking lot, instead of using asphalt or concrete, if we leave the soil to be as what it is, so if we don't change the imperviousness to if we don't change the perviousness to imperviousness, that is a non-structural LID as well. Or try to use the natural drainage of our subdivision. However, on the other hand, we have structural LIDs, which are not limited to these, but are bioretention, permeable pavements, green roofs, soakaway pit, also known as soak pit, and etc. So we will start with the most common ones that are also available in Visual OTTHYMO as well. So if you guys currently are a user of Visual OTTHYMO, I'm pretty sure you've seen this before in VO6, VO5. So very intuitive and easy to use. And if not, maybe you want to consider using Visual OTTHYMO. Also, it's because all the conservation authorities and in MTO and in the stormwater submissions guidelines, OTTHYMO engine softwares, including Visual OTTHYMO, is the most recommended one in Ontario. So Soakaway Pit or Soak Pit is a covered, permeably walled, chamber filled with clean stone to receive runoff and allows it to slowly infiltrate to the native soil. All of these text aside, a picture can explain it better. So this is a shape of a soak pit. So the pros and cons of the soak pit. The pros of the soak pit is it is very easy to construct. Also, it is for any small area. If you have a small area and if you want to slowly control the flooding or control a bit of the runoff, the excessive amount of runoff that your land development is going to generate, soak pit is a great idea. And also it's going to help recharging the groundwater. And also it's less expensive than a lot of other LID features or LID practices. However, on the other hand, like all other LIDs or LID practices, it needs maintenance. So we have to maintain this in terms of the treatment. For instance, if we don't treat the water before we let the water go down to that stone layer, uh, it's going to leave a lot of sediment there. And if that happens, we need to actually maintain that stone area. Also, on the other hand, if we don't treat the water before we want to infiltrate the water, before we want to let the water infiltrate to the native soil, it is going to be a hazard for the groundwater table. Also, another disadvantage of soak pit is when we do have seasonally high groundwater table, we may have a saturated layer, so it may not actually work. So we have to take all of these into consideration. And then the way it works is we're going to have the water here, so it's going to infiltrate down here. We need to make sure that so the water will actually come from here. I'm sorry. The water will flow to the soil, to the stone area here, and then we either can let the water get out from the under drain, or we can just let it go and infiltrate to the native soil. And whenever we have excessive amount of water here, the water will outflow back to other water or plants, or it's going to come back to as a runoff in our system. Permeable pavement that had been used recently a lot in Ontario is a permeable surface, which mostly is pavement, that allows water to go through and to a stone storage. It's going to infiltrate to a native soil. So as you see here, so the pavement that we have is going to allow the water to go to that stone storage area, and then from there it's going to infiltrate to a native soil around itself. The pros and cons of the permeable pavement. The pros of permeable pavement: it reduces the imperviousness, which clearly is a great deal for a lot of our locations, especially when we come to land development. Water quality and quantity control for permeable pavement, and also it filter the pollutants. So technically, it traps the total suspended solid. So it actually traps a lot of the pollutants, which is a great idea for in having a permeable pavement as an LID practice. However, on the other hand, again, we need to maintain our permeable pavement because of sedimentation, and again, seasonally high groundwater level based on our site, we need to reconsider about permeable pavement, or we need to take care about that groundwater table in our design. Rain garden. A rain garden is a surface ponding area that allows the water to go through the engineered soil. By engineered soil, we mean that a type of soil that we add to our site. It's not necessarily the native soil. It's not the soil that is already there. But because we want to store the water there, and we want to treat the water or treat the runoff there, and then from there we want that water to infiltrate to the native soil. As you guys see here, this is the ponding area, this is the engineered soil, and this is the native soil. So the water will actually infiltrate here, somehow infiltrate and store, and then treat here and store, and then infiltrate to the native soil. The pros: very easy to construct, and also it's a very beautiful thing to make. So it's a scenery for our site, and quality and quantity control for stormwater. However, the cons. So one of the disadvantages is technically rain garden is a small area practice, so it has a small impact on our excessive amount of runoff that we're generating. So landscaping is needed for rain garden, and also sometimes it clogs, so we need to make sure to maintain it properly. And if we also have a steep slope, if it is down the hill or if we have a hill area, it's not a good practice to conduct. Today we are going to design one of these rain gardens in Visual OTTHYMO. So just a heads up, I'm going to create a big rain garden. For planning level, how in reality it doesn't make sense to have a huge, like a very, very big in terms of area rain garden, but in terms of planning, it is actually reasonable to do so. So we're going to design one of the rain gardens today. Bioretention. Bioretention is an engineered soil to store and treat the runoff, and then it goes to a storage layer to detain larger volumes of water, and in that case, then the water can infiltrate to a surrounding native soil. This is how it looks like. Again, the pros: easy to construct, not as easy as the rain garden, but it is easy enough, or it is easy to construct, and also it's less expensive than we thought it is, and the quality and quantity control for the stormwater helps recharging the groundwater. Another thing is it is a very, very beautiful scenery for our site as well. And also, the disadvantages are, again, we need to maintain it. Sedimentation is a big deal for that. Public education. Um, Believe it or not, I've seen people uh, swim in bioretentions, like kids going for type of like swims and playing around with it. So we need to educate public how to behave around the bioretentions. And also, if we also have a groundwater table, which is seasonally become higher than normal, we also need to take that into consideration when we're designing our bioretentions. We also have enhanced swales. The enhanced swales are the vegetated open channels designed to convey, treat, and store the stormwater runoff. We have two types of enhanced swales. We have dry swales and we have wet swales. And so the only difference is that the dry swales has an additional storage layer. So this is the enhanced swale. The pros is very easy to construct, less expensive. Live in London, I've seen a lot of the enhanced swales. So Upper Thames River Conservation Authority did a fantastic job in LIDs, both in their site, which is Fanshawe Lake. If you guys ever come to London, Ontario, I highly recommend going there and taking a look. It's beautiful. And also throughout London, we see a lot of LIDs, including the enhanced swells. So it's very affordable, and also it is good for both quality and quantity control of stormwater. And also, because of the ripraps, it controls the velocity of the storm as well. Um, on the other hand, it needs maintenance, potential flies and odor, so especially for wet swales. But it can be taken care of by the type of vegetation cover that we have around the swale. So um, we just need to take them into consideration. And also, if we have a hail, it's not a good idea to go with the enhanced swale. The green roof is a layer covered with growing media and vegetation and a storage area for rainfall water to infiltrate and enables the evapotranspiration of the storm water. We have two types of green roof. One is the subsurface ponding and the other one is the surface ponding. What's the difference and what does it look like? This is the subsurface ponding. We do have the ponding to store the water and let the evapotranspiration happen in the bottom of the vegetation area of ours. Uh, so the pros and cons of both of them, subsurface ponding and the surface ponding, are the same. This is the surface ponding. So the pros are it's good for urban area, especially for the places that we are just growing so fast. It is a fantastic idea to have the green roof on the top of the places and apartments and tall buildings because it's good for both quality and quantity control. The urban heat is a big deal. What is urban heat? The urban heat is the impact of a dense uh, uh, populated area, densely populated area, like let's say Toronto area, downtown Toronto. The temperature of downtown Toronto technically is higher, in average, higher than uh, like the countries around Toronto area, like Georgetown. It's not technically because of the latitude and the longitude or the difference between the elevation. It's technically because of the urban heat, the number of cars, the number of people uh, impacts the temperature, and green roof is going to help the temperature balance at least for in a small scale, at least for that area around that green roof. So it's going to make a pleasant atmosphere for people if they want to hang out on the roof. The cons of that, however, are the maintenance again, and then it depends on the roof structure. So it's not like if we want to have a green roof, we can have the green roof wherever we want. It depends on the structure and also the equipment that we have on the rooftop. So those were two. I try to limit, and I try to um, talk less and show you guys more on visual OTTHYMO, how to model LIDs. So that's why I try to keep it as short as possible for my presentation. But what we're going to do is we're going to directly jump to the visual OTTHYMO and do some LID designs over there. So as you guys are familiar in the past sessions, the platform of Visual OTTHYMO, I'm going to open a, there we go. So let's say this is my model. I do have this model for pre-development. So this is pre-development initial. There we go. I do have my pre-development initials, and the first thing that I want to do is I want to add the water quality data to my model. So let me just delete this one. I want to show you guys how to add a water quality in our model. So in Visual OTTHYMO, if you want to add the water quality, you go to the simulation tab, the resource library. And then let's say I want to have a specific folder for that. Top group, webinar 5, and I want to add my water quality data to here. And I want to change to number 5, which is the number of. If you want, you can change the TSS or the TP, the total suspended the total suspended solids or the total phosphorus in here. So the paved surface is 90 milligram per liter and total phosphorus here. But for now, I don't want to change it. I just want to keep it as it is, as a default, and I want to add it to my model. I just click on add to model. I receive this notification saying that the water quality has been added. If you want to save this in your resource library, you can just go up there very simply and just save it there. And if not, one of the way of saving it is here. And if you're closing it, it's going to ask you if you want to save the resource library or not. I don't want to save it. So, but I do have this number 5 here, which is my water quality data. I can just double click on it. It's going to show me what the water quality of my is. So if you want, you can also change it here. But now I just want to assign the land use for hydrograph commands. Like I have one farm field here. I have woodlot, another farm field here, like 3 Nash hides up there. I have 2 other Nash hides down here as well, which connects to a river. So farm field, Nash hide number 1 flows to a river. 2 other Nash hides flows to the same river coming down. The river also will have 2 other sources of inputs for runoff from 2 other Nash hides, and then we will see the add hide at the end. So now I want to assign land use for my hydrograph commands, which are my Nash hides. I just select the Nash hide, go to properties, in the water quality, the water quality, and then these 3 dots, water quality land use group. I select it, and then as you guys see, nothing has been assigned here. So I want to assign, I want to put the percentage of what exactly is the land use of my Nash height. So for instance, farm field number, I have 9 as row crop, and then 5% is the open space, and 5% is the forest area for myself. So as this is the percentage, so 90% of my Nash height number 1 is row crop, and then 5% is the open space, 5% is the forest area. It comes to 100%, and then the area is going to be automatically generated. And then it is going to be synced with the water quality data that I provided at the very beginning. I want to do the same thing for my other Nash heights as well. Number 2, land use. So number 2, I have 95% row crop and 5% as open space, 100%. Number 3, for number 3, I have 3% paved surface. Let's put it at 3% paved surface, 8% roof because it's a wood lot, and then let's say it's 12% landscaped area. I have 77% forest, and it comes to 100% at the end. And then 2 more. One is the hay meadow. For the hay meadow, I have 80% open space, 15% forest, and 5% as my wetland, 100%. And the last one is the natural area that I have. The natural area of mine is 70% open space, 25% forest area, and 5% as my wetland, 100% in total. So these are all my land use that I have. And now what I can do is I easily can run my model. So if I want to run my model, I need to make sure that the water quality that I have here, I need to make sure that I put it as 5. These are the water quality data that I provided. So I would put them all as 5. And then I would run my model. My model is run. And I easily can check out the result, which are shown as the label here. So this was only an approach to add the water quality to my single event modeling in Visual OTTHYMO. So again, if you guys have any question, feel free to ask any type of question that you guys have in the chat area in the webinar. So if I want to add LIDs now, I will open my post-development initial. So post-development initial. Now, instead of those Nash heights that I had, I don't have the Nash heights anymore. I changed them to stand, and then now I have to work with the stand height outline. So there are 1, 2, 3 3 stand heights added instead of 3 Nash heights that I used to have. So what I want to do is I want to stretch these ones because I am going to add more commands to these ones, which are my LIDs. All right. So there we go. I want to add one. So first of all, before I want to start working with the initial, I am going to duplicate this scenario. So post-development initial, I want to duplicate it, the commands and the runs. So this is post-development initials. I rename it to post-development LIDs. So post-development with LIDs, then now I can add different LID commands to my work area, to my work area. What I want to do is I want to add one rain garden here, which is going to be after my river. So the first stand high is going to flow to the river, and the river is going to flow to the rain garden, and then the rain garden is going to come to this ad height. And then after this residential subdivision, I want to have a bioretention here. So what I can do is I have to delete the outlet of this river. So I just click on this river, I select the river, go to properties, and the outlet, I will just delete the outlet. And then as you guys see, the outlet has been deleted from river 6 to ad height number 7. Same thing with the residential subdivision 2. The outlet of that is going to be deleted. And then now I want to add my bioretention here, as well as I want to add my rain garden here. So I easily can go drag and drop the rain garden here. And as you guys see, the rain garden automatically will bring the junction that it has. So all I should do is connect the river to the rain garden and connect the junction to the ad height. Same thing with the residential. I drop here. The junction will come here. So I will connect the residential subdivision to the bioretention and the junction to the ad height. So I only added my with the default values of my LID commands. I just run it right now, make sure that the water qualities are all at 5 again. So I run my model, and then I want to come back and set the parameters for my rain garden as well as my bioretention. So for my bioretention, I want to keep the same things that we have here. One thing that I want to change is the surface ponding layer. So the depth area curve with these 3. So I just click on it. So this is the this is the stage area. So I want to switch it. I want to change them to something new. I want to say so it's 0 and the area is 0 as well. And then I want to keep it linear. I would say that the stage is 0.2 meter. The area will be 2000 square meter. There we go. So this is what I will have. So if you guys have a stage area or a depth area curve for your bioretention, you can easily just add it here. It works like an Excel sheet, so you can just work with it and then have your own. For this example, the other thing that I want to change is the mulch area depth of mine. So all I need to do is go into mulch layer. The depth of mine is 0.075. 0.075. I want to keep the porosity as it is. The engineered soil layer, I want to change the width of it to 20, the length of it to 100, the native soil, the texture of my native soil, I want to change it. You can change it to whatever you want. We have a lot of them here, but I want to change it, let's say, to sandy loam. And also the infiltration rate is going to be automatically updated based on what we have. However, if you have a different infiltration rate for your soil texture, you can just edit it here. And then At the end, also, I want to keep the same default for the water quality remover efficiency for TSS and TP. 75% of TSS is going to be removed, and TP, 25% of total phosphorus is going to be removed. So this is my parameters for my bioretention. And now I want to go back to my rain garden. As I said, the rain garden is technically and mostly a small area, but for planning level, it is okay if you guys want to have a big, let's say, rain garden. Another thing that we need to take into consideration is rain garden in Visual OTTHYMO. You do not have an option for entering a under drain or outflow structure. So if you want to have a rain garden that you want to design an under drain or outflow structure, if you want to include them into your design, you should use a bioretention command. The reason is because we don't have the rain garden with the under drain and outflow, but if you use the bioretention for you, and it's gonna provide the need of what you guys want to do. If you want to, again, if you want to add an under drained or outflow structure to your rain garden. So at the very first thing that I want to know is I want to know the size of this rain garden. The size of this rain garden should be big enough to accept the runoff volume upstream. What is the upstream? The upstream is this river. So this river of mine, I need to understand the volume of water from this river. So I need to multiply the area of it of volume of it. So what I need to do is I need to click on the river number 6, the river 6 here. When I click on it, I will go to hydrograph result. But this rain garden, just a heads up for just to double check with you guys, this rain garden is designed based on Pickering 25 millimeter 4-hour Chicago storm event. It's not based on the other ones. So it depends on the type of storm event that you want to design this rain garden for. I want to design it based on Pickering 25 millimeter 4-hour Chicago storm event. So I need to understand, based on this storm event, how much water will come to this rain garden so that I can size my rain garden. I click on River 6. I will come to Simulation tab, Hydrograph result, and it comes here. So I will click on it. Make sure that the run is based on the Pickering 25 millimeter 4-hour Chicago storm event. So what I need to know, what I need to do is multiply the area by the runoff volume RV, which is 10.981. So 10.981 times 5 is 54.9. So technically, I also forgot the change in the unit. So I have 5 acre, I have 10.981. Also, each acre is 10,000 meter. Also, each meter is 1,000 millimeters, so I have to divide it by 1,000. Oh, yeah, there we go. Now it makes sense. Now the size of my rain garden should be 549 cubic meter. So 549, or let's say 550 cubic meter should be the size of my rain garden. So I will go back to my rain garden. The size of rain garden, when we say that the storage or the size of it, it should be the size of these two, the surface ponding area plus the engineered soil layer. So the size of 1 and 2 should be 550-ish. Or at least it should be 550. That's a better terminology to use. So I will select my rain garden, properties. In the properties, I will go to surface ponding layer, and then the depth area curve, I will select it. So for this stage, I want the stage to be, the interval of the stage, I want it to be 0.1 meter. So 0.1, then 0.2, and then 0.3. And then the area at first, as I said, I want to design a very big rain garden. So 1500, and then the next one 1700, then 2100, and then 2600. So calculating the volume of this is going to be roughly around 590, 580-ish. So this is only the surface ponding area. We also have engineered soil layer. So as you guys remember, we should be around 590 to be safe, at least. So 580, 585 of that is going to be surface ponding area. The rest, I want to put it in the engineered soil layer. And in order to get the volume or the storage of the engineered soil layer, what I need to do is I need to multiply the width by the length, by the depth, by the porosity. So the width of it is going to be 15. The length is 100. The depth is not 1 meter, it's 50 centimeter. And also I will keep the porosity as it is. I will bring the calculator back up again. 0.5 times 0.463. So it's 347, so we're safe. So 385 is 932, so we're safe with size is accurate enough because of the amount of flow or amount of the volume of runoff that we're getting from this river. So now all I need to do is I want to go down here, and then the native soil of mine, I want to change it to silty clay loam. The infiltration rate of that is also accurate, and I want to keep the water quality removal efficiency as well. So the TSS and the TP removal rates are 75 and 25%. So everything set, and all I need to do is I need to run my model now. So the water quality again is just make sure that the water quality, we do have some value for that, because if we can also select not to simulate the water quality, but I want to simulate the water quality of mine as well. So the model is run successfully. One thing that I want to mention is now we did a lot of practice to preserve add height number 7. So if this is our outfall, we're trying to preserve it by putting LIDs after our developments. We have one development here. I put one LID to control the flooding. We had one development here. I put one LID here to control the flooding for here. However, we didn't do much for this commercial with wetland, which is a huge area, and it contributes to a amount of runoff that is coming out. So we don't have any LID here. So potentially these LIDs that we worked with upstream wouldn't do much for controlling the excessive amount of runoff that we're getting downstream here. But we're going to scenarios to see what exactly we did. Compare scenarios. So let me post-development initials. So this is without any LID. So I'm just going to quickly run this as well. If I run this, then I can compare that post-development with LID and without LID. The differences between them are going to be surprising. So post-development initials, post-development solved, I'm sorry. Post-development solved. Oh, it's not the one. There we go. So post-development initials and post-development LIDs. If I want to compare different scenarios, pre-development initial, I would call it as green. With LID, I would call it as black, and post-development with blue initial, I would call it as red. So this is post-development initial, but this is the natural area. What I want is number 7, the one that I try to preserve. So when we select that one, this is the 2-year event. As you guys see here, I can zoom in that one. So this huge peak of runoff is the runoff that we get with our proposed land development without any mitigation or without any flood control. And this green one was the initial one, was pre-development. However, with my LID practices that I brought, I was able to cut a lot of these runoffs and control a lot of these storm water runoffs and brought it down here. However, if I want to do the same thing for Adhide 9, which was downstream, we will see that the LID, because it was just done for upstream and nothing for downstream, it didn't do much. This is exactly what I was talking about. It did do a lot for the of my hydrograph for when I have LID, but because I didn't do much for downstream, since I didn't do much for downstream, the amount of runoff, the peak captured or controlled that much. So that was the presentation today. We are running low out of time. So I'm just going to save this project. So if you guys have any question, we already, I believe we already passed 1 hour based on my time up there. So if you guys have any question, feel free to ask. I'll be more than happy. And again, I'm sorry if you had to deal with my voice. I did all of my best to be able to speak and present. If you guys have any question, feel free to ask. Even if you have any question down the road afterwards, feel free to email me. We're always there in Smart City Water to help you guys out. All right, I will take that as a no. Thank you so very much for staying with us. That was just 2 LID out of the many LIDs that Visual OTTHYMO has. In have 8 LIDs that you can easily drag and drop and do it. We have Soakaway Pit, we have Chamber, we have Permeable Pavement, we have Rain Garden, we have Filter as well, only for quality quality control of the water. And also we have Enhanced Swell, we have Bioretention, and we have Green Roof. These 8 are already embedded in the software in Visual OTTHYMO. Also, currently we are on a promotion for Canada Day. If you guys want to start working with Visual OTTHYMO now is the time. If you guys are currently using Visual OTTHYMO, now is the best time to increase the number of users to your current, because we do have two types of license. We have a single license and we have a flexible license. The single license will stick to one computer, but a flexible license with, for instance, one user or two user, let's say two user, you can install it on as many computer as you want, and only two computer at the same time can open it. You can also install it on your personal computer. So be there for you guys whenever you want. This video is also going to be published on our YouTube channel, probably in a day or two or three, but we'll see. And but just keep checking it out, and for sure it's going to be out in 2 days. But yeah, thank you so very much. That was the 5th session of Smart City Waters webinar, Low Impact Development using Visual OTTHYMO. The next session, we're going to talk about the GIS functions in OTTHYMO. Thank you so very much. Stay safe, please. COVID-19 is not over. And thank you so very much, and we'll see each other soon. Cheers.